Well, I wanted to thank you all for joining this webinar and welcome to the first in a short series of webinars that we are putting together on data sharing software in action in the ocean space. For those of you who don't know me, my name is Adam Leadbetter, and I am the lead of the Decade Coordination Office for Ocean Data Sharing in the UN Decade of Ocean Science for Sustainable Development. The UN Ocean Decade is organized around 10 challenges, and challenge 8 is to build a digital representation of the ocean by 2030. This webinar is really helping to broadcast some of the technology that can be used in building that digital representation of the ocean. At this stage, I want to thank Fondation NG for their support in resourcing the Decade Coordination Office for Ocean Data Sharing. And I would also like to thank the International Oceanographic Data and Information Exchange of the Intergovernmental Oceanographic Commission, or IOC, of UNESCO for hosting our Decade Coordination Office. I believe that your microphones should be turned off, but we would ask you to keep your microphones muted during the webinar. We're recording the session, so you may, again, wish to just rename yourself if you want to remain anonymous. If you have questions for our presenters this afternoon, please use the chat or the Q&A function in Teams to ask questions. We will put your questions to the presenters after they have finished their talks. To achieve the goal of building a digital representation of the ocean, we need to broaden the adoption of software that is used to share ocean data in a way that is representative of ownership of the data, recognizes licensing of data, but is also as open as possible and shares data as openly as possible. Today, we'll look at some of the practical benefits that data sharing technology brings. We recognize that there are many different data sharing tools and software available. Some are based on standards by the Open Geospatial Consortium. Others are based on different standards like the Data Access Protocol, or DAP, which we will concentrate on in this series. There are other tools that are less standardized that can still share data, and those tools have been developed by a range of companies and other organizations of various sizes. Using any of these tools to share data is better than not sharing data at all as we look to build this digital representation of the ocean. But what we do need to do is work towards the use of standards-based data sharing tools to lower the effort in creating an aggregated digital representation of the ocean. Both today and later in this webinar series, we'll hear about community profiles of attributes, such as the climate and forecast conventions, which can be applied across different tools to enable data exchange. We will also look at progress the wider community has made in connecting data sharing software and tools to new data analysis paradigms, such as AI. However, in the webinars of this series, we will focus in particular on the open source ERDDAP tool. It follows much of the Data Access Protocol standard, and perhaps as importantly, has a large community of users and developers. ERDDAP can be connected as soon as it's installed without any extra configuration to IOC's Ocean Data and Information System, a growing network of data around the ocean. So while we will open and close this series with more generic presentations, the central portion of the content will focus on the ERDDAP software tool. In today's session, we will hear from Tara Keena, a data manager at Islands Marine Institute, about some of the outreach and decision-making tools which the Marine Institute has been able to build and make publicly available through the use of data sharing software. We'll also hear from Kevin O'Brien from the University of Washington in the US. Kevin is Vice Chair for Data in the Observations Coordination Group of the Global Ocean Observing System. Kevin will talk about why we should be using open tools to share data and the importance of building communities around these tools, and highlight some of the benefits of the ERDDAP tool in particular. So I'd like to thank you all again for joining and making the time to be with us this afternoon. It's great to see so many people interested in a topic that's very close to my heart. And I'd like to hand over now to Tara.
Okay, hi everyone. I'm just trying to share again, Adam, which I just did a second ago. Now, can you see? It's not in full mode, but can you see my screen?
It's on its way.
Yeah.
Yeah.
Can you see? Yeah.
Yeah.
Okay, perfect. And it's in presenter mode?
It is.
Great.
Yeah.
Okay. So hi everyone. My name is Tara Keena, and as Adam mentioned, I'm here on the behalf of the Marine Institute in Ireland. So thanks Adam and the team for having me here today as part of this webinar series on data sharing. So today's talk, it's really a high-level presentation on the importance of data sharing software from a Marine Institute perspective. So just for content, I'll give a quick overview of the Marine Institute for those of you not familiar with us, where and why we share data, some of the challenges around sharing data, the software we use, and then I'll run through some user stories or examples, and then just a quick recap at the end. So who we are and what do we do? So the Marine Institute, we're a state agency and we provide scientific and technical advice to government. We have many data acquisition platforms, programs, service areas. We manage a range of data from fisheries and ecosystems data to marine environment to oceanographic data, seabed mapping as well, for example. We're also a designated National Oceanographic Data Centre, so data sharing is key to what we do. Here's an infographic illustration where we share data to and the range of users. So it gives a good idea of the extent of our data sharing. This is actually an infographic, thanks to Adam, developed by Adam a few years ago when it's time in the Marine Institute, but it's really useful just to see the extent of data sharing. It's underpinned as well, data sharing, by a number of requirements and drivers. These are from legislative and policy based to community and best practice initiatives. So our challenges then, of course, there are many challenges with sharing data and data sharing software. You have, first of all, we've lots of different requirements for data sharing. And so this also creates a spectrum of different users with different data needs and various data literacy. So some users might want direct access to data in different formats, while other users might require just shared through visualization tools or which are easy to explore. So we have to consider how to cater for all the different users. Of course, there's also always technical challenges with sharing data. So how do you manage different file types from gridded data, tabular data to spatial data? And of course, how do you manage the increasing volumes, which it's always increasing. It's also important as well for us that software sharing solutions meet certain criteria. Well firstly, that it's easy to share the data with less overhead, and also that software that's community driven or well supported is very important. So with all this in mind, what is the solution for data sharing? We recognize there might not be just one solution that meets every requirement, but I think we've limited to a few. And here is our set of solutions in our software ecosystem within the Marine Institute. So we have, every component has its purpose, but ERDDAP really is our primary data sharing software for scientific data, which it's easy accessible in multiple formats. We also have thread server as well to share multidimensional data sets such as model outputs, and we make use as well of ArcGIS server to share geospatial data sets. And then we have a GeoNetwork software, which is open source software for our catalog, where data sets can be found and discovered. So I'll just focus a little bit on ERDDAP because as I said, it is our primary data sharing software. It really does simplify our data sharing. We currently have 85 data sets, actually 86 I think now, on ERDDAP and growing. The Marine Institute were early adopters of it, thanks to Damien Smith. I think he said almost 20 years ago he started looking into it, and today it is our primary data sharing software. It's open source with a very strong community support, and it's easy to configure ERDDAP to serve data and metadata that complies with standards and data formats. I won't go into any of the technical aspects now because I'm sure they'll be discussed by others who know a lot more than I do later on in the series. But just to mention, there are a lot of tools being built in ERDDAP, new developments all the time, and many of which will be presented in the webinar series. Within the Marine Institute, we have different sources. Just a diagram here, just showing the different sources feeding our ERDDAP, and then it provides access to the data in different formats via these URLs. ERDDAP is also really useful because it can feed other tools and dashboards to visualize or download data as well. And it's also really easy to use with scripting languages. So we've a lot of Jupyter notebooks, for example, connected to ERDDAP and pulling data from there. So I thought it might be just useful to go through some user stories that we have around data sharing. So here are some actual real examples and requests that we get within the Marine Institute. And I'll show you how ERDDAP facilitates this data sharing, and also an example as well of one of the spatial data sets with ArcGIS Server. So first up is an example of an oceanographer looking for observed tide data to validate their models in Dublin Bay. So here is our data catalog, and this is where we point users to, where they can view the metadata. You can also see the download links here to access the data. Again, it's ERDDAP providing the data behind the scenes. So I won't click on these now, but we can go to ERDDAP and show you how to access the data there as well. You can see 85 data sets, find the tide gauge data set. You can navigate then to the data access form, which will appear now. Yep, and then you can easily go to access form. It's easily subset based on, say, temporal range or the location of the gauges, whatever you're interested in. And then you can view the data in HTML just to see what it looks like. And then you can also go back and select different formats as well, because our ERDDAP offers many different formats. So I'll just select CSV in this case and download. So again, this is an example of sharing a large data set that's easily subsetted and outputted in one of different number of formats. And it's also, as you can see, quite fast. It's very fast. So here's the same example, but this time instead of going directly to ERDDAP, the user can go to one of our portals, which is fed by ERDDAP and some other data sources as well that visualizes and accesses data. So this is digitalocean.ie. You can see tide gauges, weather buoys are included, and the bathymetry, which you just saw there. So a lot of data is pulled in from ERDDAP and other sources. You can view locations of tide gauges, click on it, this case Dublin Port. Again, it shows how ERDDAP can be used to share data in many ways. You can access ERDDAP directly, or you can plug it into dashboards and other tools, and combining it as well with other data sets from ERDDAP or other sources. And finally then, using the same example, here is a custom data access form where users can subset the data and select formats, again, all fed by ERDDAP. It's building the ERDDAP URL behind the scenes and fetching the data. So again, it's seamless and easy to the end user using it. So second user story, I'll just run through sharing spatial data with ArcGIS Server. So this is an aquaculture site manager who wants to view licensed sites in their area. It's an example of some of our spatial data sets using decision support tools. So in this case, it's to assist with the management of aquaculture sites. Again, it's fed by ArcGIS Server. The data sharing includes licensed sites and other areas of interest. So they might include special protected areas, for example. So what this does really enables marine data and information to be available to everybody and really support in decision making. So this is just showing you a project done in conjunction with our parent department of Agriculture, Food and the Marine here in Ireland. Just another user story then is based on a request from a student who wanted to analyse wave height and met buoys for surf forecasting. So we can direct the user to ERDDAP as previously shown, or here's another example of a different dashboard built on ERDDAP to visualize and explore this data. So this was developed in Python and it's using ERDDAP URLs to easily subset the data. And again, it's another example of powerful tools that we created for different users. And again, all built in ERDDAP, feeding the data behind the scenes. And last example then, so this has got to do with a DOI request or a digital object identifier, so users can have a citable and discoverable dataset. So we mint DOIs within the Marine Institute and we make the associated datasets available. Again, we have a catalog entry here with the access to the dataset as well as the DOI and the citation. So here's an example of suggested citation with the DOI. So as well as this, ERDDAP here's access to data. So as well as this, ERDDAP can also have associated metadata. So we can include the citation here also embedded within ERDDAP. So this is another really useful example of data sharing with ERDDAP, but it also includes access to the data, but also the metadata and the citation as well. Okay, so last slide then. In summary, within the Marine Institute, we have different but complementary tools for sharing data. We think this creates a strong interoperable ecosystem for sharing data. ERDDAP is our primary tool and has been for many years. It's community driven, it's well supported and continuously evolving. So overall, for us, our choices of data sharing software, they support the fair data principles, caters to many different users, and supports the important goal of collecting once and sharing many times, which of course ultimately leads to better decision making and management and protection of the marine environment. So thank you for listening today and for your time. So just to mention as well, my colleague Bob Thomas is presenting in week 4 of this seminar series, and he'll be talking about data sharing and collaboration and go into some more of the detail on the data standards. So that'll also be a really good presentation to listen to. So thanks everyone.
Thank you, Tara. That was that was great. Does anybody have any questions for Tara? I don't see any in the Q&A, but if you'd like to ask Tara a question, there's a minute or two here where you can drop a question in the chat or in the Q&A. Tara, can I maybe ask a question? Who do you think are the biggest users of the ERDDAP platform that the Marine Institute puts out? Is it scientists? Is it developers? Is it
Well, that's a good question. I think it's everybody, Adam, because
yeah.
we have a lot of networks set up, maybe like with the federated ERDDAPs that feed in various data aggregators, but then we also get data requests directly to us within the Marine Institute from members of the public, engineers. We did a report on that lately, and the data requests we get directly, and so many of them were pointing people to ERDDAP, to the data sets. So it's a real mix from students to engineers, developers, scientists, researchers, everybody. It's quite a vast user base.
So really nice. So your question in there. I think we're going to hold that one for Kevin a little bit, because I think Kevin's going to touch on that a little bit in his presentation, and then maybe we can come back to that one afterwards. So, yeah. Any other questions for Tara? It's a Q&A.
Can you see the Q&A? I have it open if you want.
So, yeah, I've got the Q&A open. Yeah. So, so I can answer one of these, which is, can you replace all the functionalities of threads using ERDDAP, or do you use both? The Marine Institute, well, ERDDAP operates as a front end to many different data sources, and threads is one of those. So it effectively, you can wrap it around threads. So that's an option, and then it kind of, but it also allows you access to other data that might not be in a thread server as well. There's a question here about open source alternatives to ArcGIS. So for the maps, has the Marine Institute played with any other software apart from ArcGIS? Yeah.
We had GeoServer instances running as well for a while, and then your open source offers maybe like QGIS, but it is an Esri based house at the moment.
Yeah. And then there's another question, which is, for building the dashboards, what are some of the other tools besides the so I guess what are you using for the UI portions of some of those dashboards that are shown there?
Well, I think you can really use anything you want. Some of them are developed with .NET and C#. You have Python-based dashboards, but it's the ERDDAP data URLs that are feeding, so you can kind of build whatever front end you want. You could plug it into maybe even Power BI or various visualization tools as well, Jupyter notebooks. Lots of options.
Brilliant. All right. Well, thank you very much, Tara. That was a great presentation. Great to see different uses of the data and the benefit of having it behind a standardized access server. So thanks for that. I'd like to hand over to Kevin for our second presentation of the afternoon. Kevin, the floor is yours.
Okay, thank you very much, Adam. And that was a really great presentation by Tara. So she made my job a little bit easier, I think. I assume you can see my screen, so just shout out if you can't. Yeah, good morning, good afternoon, everyone. My name is Kevin O'Brien. I'm from the University of Washington, working through the Cooperative Institute for Climate, Ocean, and Ecosystem Studies. I'm also the current GOOS Observations Coordination Group Vice Chair of Data and Information. And so this is a topic that's very near and dear to my heart. And today I want to talk a little bit about open source community or open source software, how it fits into the ocean community, and in particular, how we are leveraging ERDDAP to meet many of our goals. So I'm going to talk about a couple things today. I want to talk a little bit about the importance of open source tools. I'm definitely not an expert there, but I've been using open source tools for the last 25, 30 years. I want to give some examples of the open source software and tools that I'm familiar with, that I've been using in my day-to-day work. And then I'll talk more about ERDDAP, which Tara just gave a really excellent introduction to. So why open source? As I said, I'm not an expert here. I've been using open source and developing open source software for a long time. So I just pulled some of the things that I thought were really important about open source and what made it unique. And the first thing in terms of collaboration and innovation, the fact that it's a shared ecosystem allowing people to build on existing work and not having to start from scratch means that that leads to faster development, faster innovation, more people working on the same issue. And so it also breaks down these silos that can be created as we all sort of work on the same problem and multiply that over many, many different projects. So breaking down those silos makes us more efficient in sharing code to do that. It is a very big thing in democratizing access to these tools. There are no expensive license fees. That's really important. Really, not sure what happened there. Sorry. That's very important for those that may not be able to afford $1,000 software license fee every month. So I think it fosters that inclusivity that is really important for driving innovation as well. In terms of transparency and reproducibility, I mean, open source means that people can look at the code, and that's what's really important. Building trust, that's one thing that I know is very critical from a data side of things. When we're working with scientists, it's really important to build tools that the scientists can trust, and open source software provides us an avenue to allow that to happen. It also improves sustainability. The data community is always fighting for research dollars. We're always fighting for support. It's an important aspect of the value chain, but it's also not a very well-funded one. And so open source software allows us to have this community-owned effort so that it can be maintained by a dedicated community who is passionate about what they're doing and can learn from other users and developers. And it's adaptable. This allows us to have different perspectives to meet and evolve new challenges over time. So today I'm going to focus on the NetCDF and Climate Forecast metadata conventions, which I'm familiar with, and I'll talk about those briefly. I'll talk a little bit about the data access protocol, which we heard about already, and then we'll go into more of an ERDDAP sort of general discussion and some of the benefits and what makes ERDDAP unique. So going in the Wayback Machine, way back before cell phones were invented. That's if we can even think about that. So NetCDF goes way back to its origins back in the late 80s, early 90s, where it was developed by Unidata. It stands for the Network Common Data Format. It was really created to provide a self-describing, meaning the metadata stays with the data. And that's important because at that time we were passing files around. We didn't really have web servers. So if you got a data file and you didn't understand what was in it, that made it really not very useful. The other thing it really addressed was this machine independent file format, so that you could write a data file on an IBM machine, send it over to a Sun Spark machine, and you could read it. So those were two very important and crucial developments that set NetCDF apart at the time. It became widely used within the scientific community, which meant that people were doing their own things. So they were calling variable names differently, and they were using different units. And this sort of decreased the interoperability because of that. So that's when the birth of the CF conventions came about. So they're not the CF conventions are not a file format. They're a set of standards that define how variables are named in a file, what the units should be used, what those canonical units are, and other descriptions with the variables. So CF conventions are rules that are applied to these netcdf files that make them more interoperable, so that software, now we can get software that understands these files. Better automation, because the standardized metadata enables this sort of machine-to-machine view on files, and also, the reproducibility. So you can see, way back here in the early 2000s, we are already sort of building toward this idea of fair compliance. These are the same sort of principles that we look to now in the fair compliances. So a little bit about the data access protocol. Again, this was something that was developed. So back in the 90s, it was something that was way ahead of its time. It was open source as well, and a web-based protocol that basically provided a standardized way to access data across the internet. So at the time, that meant if you were sitting on your laptop or whatever in the United States, you could access a data set in Spain as if it was on your local desktop. And at the time, it was revolutionary. In fact, it still is. I mean, I think it was really ahead of its time in doing this. It was one of the first attempts to obfuscate users from data formats so that they were just using the data that they wanted. It also allowed users to access just a subset of data from a remote service. So rather than transferring a bunch of data where you only need a little bit, you could actually just pull that subset out. And that was a big deal back then when internet latencies weren't a lot higher. And so there were several DAP-based tools that came out. I'm just going to focus on the three that I'm more familiar with. The first is called Hyrax, and this is developed by OpenDAC Inc. That is led by James Gallagher, who was the original developers of, at the time it was called the Distributed Ocean Data System, or DOS, that led to the DAP protocol. Hyrax is C++ based software that is used to access these large scientific data sets. It was really NASA funded, so it has a very big focus on satellite data. Threads, which we heard about a little bit earlier, was developed through the Unidata, through National Science Foundation funding. And they also developed the netcdf Java libraries that were integral in the Threads software to connect to the netcdf, the netcdf libraries. This also makes large aggregate data sets available over the web. Threads was kind of the first tool that looked at taking these individual platform observations and making collections of them through join existing and join union type of aggregations that they made. One of the strengths of Threads is its ability to handle these complex grids like curvilinear grids or unstructured grids. And then the last one is ERDDAP, which I'll just kind of go into the discussion about ERDDAP. We heard a little bit about it. So what is ERDDAP? I'm going to go into more detail on that. So basically, ERDDAP, as you glean from Tara's excellent presentation, it's a data server or a data broker or a data mediator, however you want to call it, that is designed to deliver data and metadata easily from any data source into the user's favorite client or software. So again, it's one of these tools that obfuscates the format of the desired data so that the user can just do the things they want to do with the clients that they're used to doing it with. This was developed by Bob Simons back at NOAA Southwest Fisheries Science Center. Bob has been retired for about 3 years now. We've been lucky to find there's Chris John, who is now the ERDDAP technical director and lead developer, who was working with ERDDAP before Bob retired and has since taken over the lead on that development and has done an amazing job, as we'll talk about a little bit later, but moving that into a sort of an open source environment. And so the bottom line is that ERDDAP is this really valuable tool that we're using in lots and lots of places to help organizations, to help projects, to help individuals comply with their fair compliance principles. And there's the ERDDAP GitHub address for those that are interested. We'll talk more about that. So just a little bit on the ERDDAP governance. There's a couple of active groups that are currently working right now and in session. The Strategic Insight Group, or the SIG, that is something that I co-chair with, with Matt Biddle at USIUS, the Integrated Ocean Observing System. I would like to credit Matt because I did crib some of his slides that are coming up from a recent presentation he made. But that the goal of that group is to promote ERDDAP use and adoption, which is one of the reasons, this is supported by that group, this type of webinar series. We're also looking to ensure that the support for ERDDAP remains stable moving forward, and we've done a really good job at influence NOAA at the highest levels of identifying ERDDAP as a NOAA identified dissemination tool. So it has lots of support within NOAA. There's also a technical board, and this is chaired by Chris, and it has several members, 4 or 5 members at this point, and they meet, I believe it's monthly, to talk about technical direction of ERDDAP, what is the priority for new development, and what do future roadmaps look like. And so these are things that never really happened in the past, so it's really great to have this interaction with the community. These technical board meetings are open to the public for those that may want to sit and listen in, and you can see a little bit more information about the groups there at the GitHub link. So, okay, so that's kind of the boring stuff. Now the exciting stuff. What is ERDDAP and what makes it different? What sets it apart? And I'm just going to walk through some of the things that I think that are really important about ERDDAP that really set it apart. The one thing that makes ERDDAP really powerful, one of the things that makes it really powerful, is that it both connects to a wide variety of data formats, which you see on the left side of this crazy graph that Matt put together. A lot of different formats, from ASCII files, from databases, from NetCDF files, from OBIS Parquet files, from Amazon S3, a lot of different data sources, but then it also provides output to users in a lot of different data formats, so that if you're interested in an OBIS data set, but you want to look at it in NetCDF, how does that work? ERDDAP can mediate that conversion for you. And so there's a huge value in not having to support a bunch of different file outputs if you're a data provider, and it also being able to connect to a bunch of data inputs. It's really makes life a lot easier. ERDDAP has this really amazing ability to federate other ERDDAP servers, and this is something that is incredibly useful across organizations. So you can imagine 4 different ERDDAP servers here in this very similar graph that Matt put together. You federate those 4 ERDDAPs, and anyone accessing any data set on those ERDDAPs can access it through obviously the output formats that are available. This is a very powerful feature. We are looking at leveraging this capability in the GOOS observation coordination group, in the global in situ networks, as we're trying to build a better sort of architecture of that data and the data flows there. So we're using this ERDDAP federation ability to federate on many different levels, from the individual networks all the way up to the most high-level stakeholders you could imagine, like things like the UN Ocean Decade, Ditto, those sorts of things. We have federations at every level, so you can connect at every level, but the top-level stakeholders really only need to know that one ERDDAP address to find out all this information and make access to this data available. So it supports both human and machine access, and Tara did a really great job of already kind of highlighting this. I will say, just to add, that I know people that are new to ERDDAP, when they see this data access form, kind of, their eyes glaze over, and it's painful, and I understand that. There's a lot of, for me, someone who's used to using it, it's comforting. It's like a hot cup of tea on a cold day. I like this, but I can understand why some don't. But that's the great thing about ERDDAP, is you can dive into this and figure out the queries that you want to make into the API. It makes it very easily, but then you build tools on top of that. And that's really how we want to interact with users for the most part. For the general user, we want to build these tools that connect directly to the ERDDAP services, but provide the same services that that complicated UI would, but in a very much more similar UI. So to answer one of the questions earlier, we're using Python and Dash and Plotly to build dashboards like this that really are highly interactive, but also provide access to the metadata, to the individual data points, etc. So this is really one of the strengths of ERDDAP, is the very easy ability to use that API to build tools like this on top of it. Metadata is huge. It's a big issue. ERDDAP has many features that provide excellent metadata support for users. So when your data is in ERDDAP and you have properly filled out the metadata in the dataset configurations, that means that ERDDAP will automatically generate ISO 19115 compliant metadata, as well as FGDSIC compliant metadata automatically. So it's already in there. You don't have to do your own ISO generations. It's super useful. for harvesting or discovery tools, etc. Not having to manage your own ISO output, I think would be, well, for me, it's amazing. The other really nice thing that was built into ERDDAP, and this was done thanks to Adam and Rob, who worked with Bob years ago, but the schema.org and JSON-LD metadata come right out of the box from ERDDAP. So this is really important for this whole linked data world and the things that like Google dataset search are looking for to populate their search and discovery tools. We mentioned, I think Adam mentioned earlier, the International Oceanographic Data and Information Exchange has a program called the Ocean Data Information System, or ODS. This is a system that's designed to be a discovery tool for ocean data, and they look at these federated metadata catalogs. And so the way it works with ERDDAP, because the data is in ERDDAP, we can connect directly to ODS harvesting. They can come into the ERDDAP, find the information, and populate their discovery tool. And I'm working with them through Goose to make this happen, and it's worked quite well. The other thing about ERDDAP now that it's been really moved into this open source community, this open source environment. I'll note that ERDDAP was always open source. The code was always available for those that wanted it. But moving it into this community where people can go to GitHub and make pull requests and download the data and run tests and stuff, that none of that was really working in that environment. But Chris John has done an amazing job evolving that all into this nice open source community where there are people that are developing and providing updates and new code. There's also a bunch of community built tools that have been built around it. ERDDAP is a Python language that Felipe Fernandez put together, which is super useful to help you build those ERDDAP API URLs calls. There's a couple of R packages that are useful there. There's some viewers, and there's an ERDDAP Python library for the RESTful API, but there's also ERDDAP.com, which is this global search capability where you can go and search across all the ERDDAPs that are federated under that site, and you can actually add your ERDDAP to that list if you are interested in doing so. So these are a lot of the things that the community is building to make ERDDAP a more effective tool. And this is one of the strengths of this open source environment. So yeah, ERDDAP is building it. The source code is public. As I said, it has been, but now it's really embedded into the GitHub. And if you go to github.com/ERDDAP, you'll see the whole thing there. There are priority project lists that the technical board works on that identifies where things are going. There's feedback and issue tracking and issue setting from the community. So there's a lot happening at this ERDDAP page. There's an ERDDAP mailing list that's quite active. There's a lot you can learn by going to the GitHub. So, and again, kudos to Chris for really taking the time and the effort to pull all this together and make it a super effective community. And so there's been, just to highlight a few things a few of the enhancements that have been going on for ERDDAP just this summer. The US IUs group had a Google Summer of Code where they had several ERDDAP applications going on to help ERDDAP administrators, to help for different languages. One of the things that I'm very interested in testing out is MQTT protocol support for ERDDAP, which I just think is amazing, and I'm really looking forward to it. It's something that will help ERDDAP blend into the next generation of real-time data exchange, global data exchange through the World Meteorological Organization, and supporting their WMO information system, or the WIS2, which is this next generation of real-time data exchange. So that's all I was going to say. There's a ton of stuff I didn't have time to cover. Like, there's so many things that ERDDAP does, and I'm hoping that the webinar, I know that the webinar series moving forward will touch on some of these things. I think we're open to understanding what people want to hear more about and maybe providing even more targeted demonstrations. For example, you can ingest data directly into ERDDAP. So for example, think of a sensor that's connected to IoT or MQTT coming soon. When there's new data, instead of having a file that gets loaded into ERDDAP, it can get pushed right into ERDDAP, which has a lot of interesting connotations. One of those being it automatically does version control. So you have a version checker, a version control where you can go back and look at old versions of the data if something changes. There are scripting capabilities that work on the fly through the ERDDAP dataset configuration that allow you to manipulate things. So for example, if you have a file that instead of having a timestamp has different columns, it's a CSV file and has 8 different columns for month, day, year, whatever. In the ERDDAP configuration, you can write a script that takes those separate columns, puts them together, and creates an actual time word. And there's so many more things you can do with that capability. There's a lot. There's cloud features to make it more efficient on Amazon Web Services. You can subscribe and mirror ERDDAP data sets if that's what you need to do through ERDDAPs and through the federation capabilities. It does form some visualizations and provides access to JPEGs and images. There's a Docker configuration for it, and lots of people are using it. There's over 100, and this is probably old numbers, but the last numbers that we have on the ERDDAP list are 100 different institutions over 17 different countries. I would think it's more than that by now. And there's new work on showing metrics, a lot of stuff. So there's a lot of capabilities that we haven't even touched on in these presentations, but we will be hearing more about them across the coming weeks. So that, I believe, is my last slide. So yeah, thank you very much. Hopefully that was in time.
That's perfect. Thank you, Kevin. There are a couple of questions.
Okay.
Margarita, you put. Oh no. Yeah. Did you want to say something? No. Okay. Great. So first of all, can you give an idea of the cost of implementing an ERDDAP setup? What does that look like in terms of people, servers, etc.? I think we're going to see some of this next week as well, and hopefully in 20 minutes next week you'll see cold to a running ERDDAP. But maybe Kevin can just fill in a little bit more detail there.
Yeah, I think it depends on the technical capabilities of where something's being installed. But in general, ERDDAP is, well, it's free, obviously. It's a Java-based tool that needs a servlet container to run into. So that's something like Tomcat. Once you install a Tomcat and ERDDAP, it's quite easy. It's actually quite straightforward to install. I'm not familiar with the Docker, how to use Docker, but I know a lot of people use the Docker image to get it up and running as well. And there's some tutorials already on Docker that Callum Rollo did, so other folks have done. But once it's up and running, it's quite stable. I mean, that's one of the nice things over the past 15 years or so. I mean, the things like Tomcat, these servlet containers they've become much more reliable and they run pretty much, no worries. So it doesn't need a lot of maintenance. Really, I think the most complicated part is actually configuring data sets into ERDDAP, and not really complicated, but it does take some curation effort to do that. So it is super helpful to have a knowledgeable data curator to help put these data sets into ERDDAP.
So Ben Best left a message in the chat saying that ERDDAP setup is probably easiest on a server with the Docker recipe, and in fact, if you join us next week for the next session, you'll see Axiom Data Science, who set that Docker recipe up, created that Docker recipe and maintain it. Then they will walk us through going from the Docker recipe, the recipe to a running instance in the session next week. So yeah, there is another question, there's another couple of questions. Okay. So one of the questions is there a data validation step before publishing them to the server? So for me, I mean, I think you put the data behind ERDDAP at whatever point in your workflow you're ready to publish it. So as Kevin said, you can connect directly to sensors using IoT, and there may not be any data validation step, or you could put a data validation step in there. Or maybe it's data that have been fully processed, fully calibrated by a scientist, and it's in your database, whatever your database looks like, and then it goes behind the ERDDAP server to get it out to the world. So I think, I mean, for me, you make the decision about when you're publishing, and so the data validation step is part of your workflow, and you use your workflow to publish, and you have that as your final step. But I don't know, Kevin or Tara, maybe you want to chip in there?
Well, exactly what you said, Adam. ERDDAP isn't, it doesn't have anything to do with validating or any. It's going to serve the data and the metadata you put into it, and so it's definitely, the responsibility of the data provider to at least document in the metadata how, what the data set is. So
there's another great question here from Helen, which is how can nonprofits or institutions put data sharing technology like ERDDAP into their workflows and use it to start collaborating with other scientists within an organization or further afield. I think maybe Kevin, like that's pretty much what you do with Goose, right? So
well, this is exactly what we're doing with Goose. So we've recently released our data implementation strategy to provide, a better, more interoperability for the Goose in situ data streams. And so that's what we're doing. So we're really working with the data endpoint. So we try to focus on what's the data endpoint, and then let's get an ERDDAP service running at that data endpoint, whether it's through the Docker containers, whether it's through, the source, just the client, install. So that's really the main thing, is really kind of reaching out to those endpoints and saying, can you put an ERDDAP up? Here's how you do it. Can you do it? How do you need help? And how do we go forward from there? So, yeah.
Brilliant. I think that might be all the questions. Yeah.
Okay.
Great. Yeah, listen, I just want to thank everybody for joining us. I think Kevin, are you still showing your screen?
I am. Let me stop.
Yeah,
Sorry.
could you just stop? Yeah. So we do invite you to join us again next week, when we'll be running a second webinar in the series, where we'll be helping walk through what that looks like in terms of running the Docker container and getting started with ERDDAP. So we look forward to you joining us then. We'd love it if you joined our community practice within the decade. So the UN Ocean Decade encourages community practice around different themes. Data sharing, data management, and in the marine area is one of those. And if you hit the QR code that's on the screen at the moment, then you'll see a series of links, and you can join the community practice by following along the Decade Coordination Office on LinkedIn as a starting point. And then we also run drop-in sessions once a month, where people are very welcome to come along and ask any questions that you might have about ocean data sharing. I can't promise that we can answer them in those sessions, but we can certainly find people from the community who would be able to answer those questions. So maybe it would be that we would point you in the direction of Kevin or Roy or Chris, who've been talking, or other people like Tara and her colleagues from the Marine Institute. So yeah, please do follow us along on LinkedIn to see what other things are happening, and consider joining one of the drop-in sessions as well. And we look forward to seeing you next week for the second session. Thank you all.